Hello, in this video we're going to go over a sample exam from the chapters 11 and 12 of the textbook. Let u equals 2i plus j minus k, v equals 3i plus j minus 2k, and a equals 1 comma negative 1 comma 1. So we are given two vectors and 1 point. Find the angle between u and v. Okay, so in order to find the angle, we'll have to use the dot product. So we're going to find dot product of u and v. So that would be 2 plus 2 times 3, which is 6, plus 1 plus 2. So that would give us 9. And then we have to find a magnitude of u. So this is part A. Magnitude of u times magnitude of v times cosine of the angle. So this would be magnitude of u would be root 4 plus 1 plus 1. Magnitude of v would be root 9 plus 1 plus 4. And then times cosine of theta. So let's evaluate this. So we get root 6 times root 14 times cosine of theta. So what does that tell us? It means cosine of theta would be 9 over root 6 times root 14. And what is theta? Theta would be just cosine inverse of that. They didn't ask us to simplify, so we could just leave it like that. So that would be an acceptable answer. Find the symmetric equation of the line through A that is parallel to U. So it's a line through A that is parallel to U, and they're asking you for symmetric equation. So symmetric equation would look like this. So we have x, y, z, and then we put the point on the numerator. So find the symmetric equation of the line through A that is parallel to U. So A would go on top, so minus 1, plus 1, and then minus 1, because the point was 1, 1, negative 1. And it's parallel to U, so it would be 2, 1, negative 1, because U was 2i plus j minus k. The third part is find an equation of the plane parallel to both U and V that passes through A. Okay, so we are looking for a plane that is parallel to U, parallel to V, and it also goes through the point A. So if it is parallel to both of the vectors U and V, it means it would be perpendicular to their cross product. So the normal vector would be the cross product of these two. So normal vector would be U cross V or V cross U. It doesn't really matter which one you evaluate. So let's evaluate U cross V. U is 2, 1, negative 1, and V is 3, 1, negative 2. So 3, 1, negative 2. So we're going to evaluate that. That would be our normal vector, and then we're also given a point, and then we can write down the equation of the plane. So this would be I times negative 2 plus 1 minus j times negative 4 plus 3 plus k times 2 minus 3. Let's simplify to see what we get. We get minus I. This is going to be minus 1, so plus j, and then this is minus 1, so minus k. So the plane would be minus, because that's the normal vector, x minus a, the first coordinate of a, and a was 1, negative 1, 1, if I remember correctly. Yep. So x minus 1 plus 1 times y minus negative 1 plus z times, in fact, minus z times minus 1 equals 0. And they didn't ask us to simplify, so this would be our answer. So let's move on to the next problem. Let A, B, C be these 3 points. Is the triangle ABC a right triangle? Okay, so we're going to have to do, we can do two different things. We could find the 3 length and then see if they satisfy the Pythagorean theorem. Or we could find the angle, all 3 angles. So let's find the length of the vectors. So AB would be, so if the distance between A and B would be square root of, or let's do AB squared, because in the Pythagorean theorem we have AB squared plus BC squared equals AC squared. So AB squared would be 2 minus 1 squared plus minus 1 squared plus 3 minus 2 squared. 2 minus 1 squared is 1. Minus 1 is minus 2 squared. That we get 4, and then plus 1, so that would give us 6. let's find the distance between A and C. That would be 0 minus 1 or 1 minus 0 squared plus 1 minus 2 squared plus 2 minus 1 squared. So this is 1 plus 1 plus 1, so that would be 3. Let's evaluate the distance between B and C and square that. We get 2 minus 0 squared, we get negative 1 minus 2 squared, and we get 3 minus 1 squared. So this would be 4 plus 9 plus 4, which is 16 or 17. Okay, so 6 plus 3 is not equal to 17. So that tells us that ABC is not a right triangle. Okay, so this is not a right triangle. Find the area of the triangle ABC. So what's the area of a triangle? Area of a triangle is, so area of triangle ABC is, if you recall, area of a parallelogram is the magnitude of cross product. So if you have 3 points A, B, C, the parallelogram based on this would be the cross product of AB and AC divided by 2, magnitude of cross product of AB and AC. This is the parallelogram. Now, because we're looking for the area of the triangle, we'll have to divide that by 2. So we're going to evaluate AB and AC, and then we're going to find the cross product of these two, and then we're going to take the magnitude, and then we're going to divide by 2. So AB, so B minus A, 2 minus 1, that's 1, minus 1 minus 1, so that's negative 2, and then 3 minus 2, that is 1. AC, we do C minus A, so 0 minus 1, 2 minus 1, so negative 1, 1, and then the last component is negative 1. Next, we're going to cross these two. We're going to find the cross product of these two. We get I, J, K, 1, negative 2, 1, negative 1, 1, negative 1. So this would be I, 2 minus 1 minus J, negative 1 plus 1, and then plus K times 1 minus 2. So this would be I, this is 0, so we can just ignore that, and then minus J. So that means area of ABC is magnitude of this vector I minus J divided by 2. Magnitude of this is root 2, so we have to divide that by 2. So this would be the answer to this problem. Part C, find an equation of the sphere centered at A that passes through the midpoint of segment BC. So in order to find the equation of a sphere, we need the center and we need the radius. So let's draw a diagram for this. We have a point A, this is the center, and we have 2 points B and C. And they told us that the radius is the distance from A to the midpoint. So this is our radius. So first of all, we are given point A. Point A is 1, 1, 2. And we need to find the distance between A and the midpoint. Midpoint is the average. So we're going to have to take the average of B and C. Average of B and C, the x-coordinate would be 2 plus 0 over 1 over 2. So that would be 1. Y-coordinate would be minus 1 plus 2 over 2. That's 1 half. And then the third component is 3 plus 1 over 2. That is 2. So this is M. Now the radius is the distance between these two. So the radius would be the distance between A and M. So that would be square root of 1 minus 1 squared plus 1 minus 1 half squared plus 2 minus 2 squared. So that would be 1 half. So this is our radius, and the center is 1, 1, 2. So that means the equation of the sphere would be x minus 1 squared plus y minus 1 squared plus z minus 2 squared equals the radius squared. So that's the answer to this part. Okay, so let's look at number 3. The position of a particle in space is given by that. Sketch the trace of this particle and indicate the direction the curve is traced out as t increases. So let's write down the equation, let's write down the x and y and z coordinates. So x coordinate is sine t, y coordinate is 2 cosine of t, and z coordinate is -1. And they also asked us to name this curve. Okay, so what does this tell us? This is x squared plus y over 2 squared equals 1, which is an ellipse. So this is an ellipse and this is a plane. So what we have is this. It is an ellipse on the plane z equals -1. So how do we graph that? Well, we're just going to put it on the plane -1, z equals -1, which is right here at the bottom. So it would be an ellipse on this plane. Now, in order to indicate the direction in which the um, curve is traversed, we're going to plug in different values of t. So if you plug in t equals 0, x and y and z are going to be 0 to -1. So 0 to -1 is right here. So the z component, the y component is here, and let me label the axis. So this is x, y, and z axis. So it is right here. Now let's plug in t equals pi over 2. Pi over 2 gives us 1, 0, and -1. So 1, 0, -1 would be on this side, so here. So the way it is traversed is this way. Okay, so let's look at the next one. Find the curvature of this curve at t equals 0. So the formula for curvature, if you recall, was magnitude of a cross v divided by magnitude of v cubed. So the first thing is to find the velocity. So velocity is, and we're going to have to find it at t, which means by differentiating the position. So we're going to differentiate the position. We get cosine of t minus 2 sine of t and 0. And then we're going to find the acceleration. So acceleration would be minus sine t minus 2 cosine t, 0. And they said find the curvature at t equals 0. So we're going to plug in 0 first, and then we're going to do the cross product. That makes things a bit simpler. So v at 0 is going to be 1, 0, 0. A at 0, acceleration at 0, would be 0, -2, 0. Then we're going to find a cross product of these two. So v of 0 cross a of 0. And by the way, you could do v cross a or a cross v, because eventually you're taking the magnitude. So it doesn't actually matter which one you do first. So I, j, k, 1, 0, 0, 0, -2, 0. So this would be I times 0 minus 0 minus j times 0 minus 0 again, plus k times -2, which is -2k. So the curvature is going to be magnitude of this, -2k, divided by magnitude of v, which is v is just I, so magnitude of I cubed. So this is going to be 2. So the curvature is exactly 2. Okay, so let's now look at the next part of this problem. Write an integral that evaluates the length of the path traced by this particle from t equals 0 to t equals 1 and do not evaluate. So all we gotta do is to substitute the arc length formula by what we were given. So arc length is equal to integral from 0 to 1, because they said from t equals 0, if I'm correct, yeah, from t equals 0 to t equals 1. And then we're going to have to take the magnitude of velocity. So this is our answer. So all we're going to have to do is to substitute velocity in here, take its magnitude. Velocity was cosine minus 2 sine 0. So it would be square root of cosine squared t plus 4 sine squared t dt. So this is our answer. And they said do not evaluate. In fact, this is a difficult integral to evaluate. Find the tangential and normal components of acceleration at t equals 0. So we're trying to find the tangential and normal components of acceleration. So the first one is at. So what is at? If you recall, this could be obtained by taking the dot product of a and v and then dividing it by v. So this was the tangential component of acceleration. And let's go back and see what they asked us to do. They said at t equals 0, so we're going to have to take the dot product of these two. So the dot product of the two vectors 0, -2, 0, and v, which is 1, 0, 0. And then we're going to have to divide by the magnitude of v, which is 1, 0, 0. If you find the dot product of this, we get 0 over 1, which is just 0. So that's the tangential component of acceleration. The normal component of acceleration is square root of magnitude of a squared minus a sub t squared. A is this one, so we'll have to take the magnitude of this squared, that's 4. And then minus a sub t, we just found it to be 0, so we get 2. So the normal component of acceleration is in fact 2. Okay, and here is the last problem. Write a smooth parameterization for the segment from this point to that point. So let me draw a diagram for this. So the first point is 1, 2, 1, and the second point is 0, 1, -1. So we're going to write down the equation of the line, and then we're going to see what are the limitations for t. So the line can be obtained by one point and the direction vector. The direction vector is AB or BA. It doesn't matter. Either way works. -1 and -2. So this is our direction vector. So we take B minus A. So that's our direction vector. So the line would be x equals A, which is 1, y equals z equals, so we put A, and then plus the coordinates of the direction vector times t. So minus t minus t minus 2t. So this is our parameterization, and then we have to also put the limits of our parameter. So for what value of t do we get A? For 0 we get A. For what value of t do we get B? For in order for this to be 0, we need t to be 1. So the limits of the parameter are 0 and 1. So this is our parameterization. Now, the question was not to find the parameterization, the question was to find a smooth parameterization. So we'll have to see if in fact this is smooth. So let's look at smoothness of this curve. So what we do is we're going to take x prime, y prime, z prime, and we're going to see if that is in fact 0. So the derivative is -1, -1, -2, which of course is not 0. So that means this is a smooth parameterization. So that's in fact the final answer. Now you could also write it down as an alternate way of writing this down is to write it down as r of t equals 1 minus t, comma 2 minus t, comma 1 minus 2t, where t ranges from 0 to 1. That's an alternate way of writing down the parameterization. And that brings me to the end of this video. I will see you in the next video.